Thank you for having me. Hopefully, my audio is fine. You need to confirm that because it's a rush switch to my session as well. So today we are going to talk about Cloudrun, a GCP product which is I'm considering and others considering is the king of serverless services. So let's see what are those developer features that we love and how you can use this in your existing projects, or why not in a new project. So straightforward, I will go into the presentation. I will skip this part about me. You can find on Stack Overflow, and lately I published on Medium some articles that are specifically about cloud workflows, Cloudrun, and others as well. So what is serverless? What are serverless pain points is one topic that I would like to address today with you. So we are going to see how Cloudrun have brought containers to serverless. We will have 3 demos. Hopefully we will have enough time to actually demo all the others and all the best features, practical use cases. I want to showcase you with some strong pro-contra element of it. So what is serverless? In a nutshell, operational model, there is no infrastructure management. You don't need to take care of virtual machines, no need to actually have let's say a true sysadmin on it. It has some managed security, but not all the security that you can use. It has one part of it. And you pay only for usage, so you are not paying 24/7. You are only paying by request, by CPU, by memory, and all these kind of elements that are part of the serverless world. As a programming model, it's service based, or let's say application based. It can be like that. So you probably will have hundreds of applications deployed, each with their own set of context and all tailored to do their own thing. It's event driven, but this event driven is not forced, it's a feature. So you could respond to a bunch of events, or you could actually build out even applications that are workload processors or batch jobs and so on. So it's just an optional way. And nonetheless, for developers, it means it's open. So you can use your own tools, your own libraries, even if it's open source or if it's mandatory, license based. And all this can be used for the serverless model. In a previous serverless conference, so basically at Milano in 2019, Brett had a Q&A for the audience, and the answers were these results. What we need to observe here is that cold starts are one of the most voted pain points of the serverless, and some of other is that there is a vendor lock-in, so you may go serverless into one cloud vendor and not the other. Also, there are predictable billing and organizing tracing function, other pain points as well. Now, why I'm showing you this? Because I want to actually emphasize that Cloudrun arrived into the serverless world addressing all these elements of the words. So we will see how cold starts is no longer a problem. We will see vendor lock-in is no longer a problem, and it has let's say predictable billing at some sort if you can know exactly your traffic, or exactly means here that in a batch way your traffic, and you can actually predict how many requests you are going to serve, or that, and you have a threshold to actually stop what's over of the services as like that. You can place any questions in the chat. Hopefully we will get over nicely with the session. So containers, as we know, we can place any language, programming language, any library, any binary. It has an ecosystem of base images. for this conference I don't need to detail what are containers, but this is just the starting that what I'm going to talk about is about containers and packaging the code inside the container as well. So Cloud Run bringing serverless to containers. Let's see what are these. Cloud Run lets you actually to go to production in seconds. I would say it's not 1, 2, 3, but it's more like 50 or 59 hopefully. It's natively serverless, it's based on Kubernetes, and it's based on a native initiative which cloud vendors actually built out in the last few years. So you can actually run on NTOS, you can run on managed cloud, so you have choices to actually use it in a managed environment, or you can use it in an NTOS environment, which could be on-premise or on another cloud vendor and so on. And because it's containers, you have one experience where you want it. So even if it's in the cloud or on premise, you have the experience. If I need to place Cloud Run somewhere in the ecosystem, let's drive to a quick product-based drive-through. So let's see what are serverless functions. So these are cloud functions. That's the name of the product on the GCP platform to run a function. There is App Engine as well, where you could actually add a full application, and you could base your application in the App Engine. This means that you don't have a VM, you didn't have to actually select and install all the sources to the VM. You just told that this is a Node.js app, what version, what is my my product file, and all the dependencies were installed and so on. And now there is Cloud Run. This is different because so far it was source based, so you actually the deployment was the source. Here the deployment is a container which has a source at its root system, but mostly you are building containers and you are deploying containers. And here comes the fancy way, because containers can be turned on as many as we want, can be scaled down, can be set on a different hardware. They have their own mechanism to actually work nicely and connect with the network topology as well. We need to mention that currently Google Cloud Run actually lets you to run HTTP apps, so you need to have a HTTP endpoint for the healing to actually work, and the health check to check it in order if the container is responsive and so on. But in the background you can run any application, even command line applications, whatever you want. Demo. Let's see how we are going to use Cloud Run in order to get a quick demo. So I'm going to switch to the browser. This is the basic view of Google Cloud Platform. When you open your project, you get all these nice boxes here, and Cloud Run is hidden somewhere in the menu as well, but I would suggest using this search in actually to get Cloud Run application to actually loading up. So Cloud Run is here. This is the second tab. I prepared it. In our Cloud Run there is nothing right now. I deleted everything which I had here in order to show you how easy it is to actually deploy some service. We are going to use VS Code in order to deploy a service. This is my VS Code. I already set up the G-Cloud utility for the terminal in order to connect with the Google Cloud Platform, and I've installed one of the extensions to show the project of the GCP project that I'm going to use here. This project, there is an extension for the VS Code GCP project switcher. You should install it. This is actually mine, so I published this extension in order to have in the status bar a way to actually switch easily the project and to be able to work with your project nicely in the Google Cloud environment. So no projects, no services deployed. We are in the command line. I prepared a few demos, so let's use the first one. And the first one here is going to be a hello world request. I prepared some quick run tasks in VS Code, which I'm going to demo as well. So VS Code lets you to write a special .VS Code folder in which you can place a task JSON file, and there you can put your commands as well. What I want to showcase right now is this second option in my option, which means that the G-Cloud utility will deploy an application. We will name it demo1. The source will be the current folder. It will be a platform managed, so it will be on the cloud and not on an on-premise environment. It will be in the US Central, and it will be open for the public. So allow unauthenticated is a way to actually build the application. So right now I'm going to copy this command from here in order to place it here. And what's going to happen right now is that there are 5 steps that are going to happen here. One is uploading the sources. So it took my folder and it's uploading to the cloud in order to build out the container. It's building out a container. If I want to actually check the logs of the container, I have the ability to visit this URL here. And once the container is built, which is usually around 30 seconds, it's already done. You see it's okay. Next is setting the permission. We set here that it's open for the public. And then it's creating a revision. So revision 1, 2, 3, 6, 4, and so on is going to be created. Every change in the revision is done. And we are there, and this is the demo URL that we are going to see. And it's there. So this is our application, and this is in the cloud. So I didn't measure the time, but hopefully it was a few seconds, or at least 50 seconds, which I'm used to. And here is the application. It's open, and let's see now a change. So I'm going to my file, and I'm going to change hello world with hello Waxed days, and I'm now going to click this quick task from my pen, and here it's executing the same command, and it's running the same operations as well, uploading the sources and building the I can check the logs. Hopefully I still get the logs information. Something I used wrong. And so here is the container, building the container logs. You have here that it's fetching the source, it's building the container from node Alpine, it's getting the container, it's copying the source code, then it's running the npm start, and then it's pushing out. And then you will have all the layers cached, and you get the digest of it. If I switch now to my application and refresh, hopefully it will be Waxed days. So the new application is deployed. What you see here in the console is that we got revision 3. So here you have the revision 3, and all the application is there. How easy, why it was easy, and what was in the background? In the background there was a Docker file. The Docker file was a straightforward, just for this example, in order to see it how easy it is to actually deploy an application. But Google Cloud has a feature as well to actually deploy source code without a Docker file as well. It lay out services for different languages, and you can actually deploy applications for supported languages. Supported languages right now are Go, Node.js, Python, Java, .NET Core, and this way you are able to actually run a command without using a Docker container. So let's quickly see that how it's formed. I'm going to rename this Docker file, and I'm going to hit again this project. I should have added here a 2, but I did not, so I'm going to actually run it again. to actually see if it's going to create the right service and the right update as well. In the interface, if I go back to this interface, in the interface I'm seeing the application. It's the application, it doesn't have any traffic, but I could add a burst of traffic in order to see. Here you have diagrams for the traffic that's going to hit your container. You can go with, for example, request latencies is something that I'm also checking in the trace as well and in the metrics explorer. So you are actually taken to full center to analyze all the elements of the request latencies. You don't have here too much data because this is just a basic service for you. So this is still building out. Yeah, it's a longer process a bit, but it finished building the container. It's a longer process because it doesn't uses the, let's say, industry best containers, which I've chosen as an Alpine container. It uses the slim container, but it's there. So this is our application built without Docker container. How did it happen? There is a service called buildpacks, and buildpacks is a universal way to actually let me locate. So buildpacks, where is here? Buildpacks. So it's built on buildpacks, and buildpacks is a service that automatically detects based on your folder what language, what version, what product, what features you are actually running this application, and it gets a way to identify what version of your package is going to run on, and it will build the package out of the box for you. This is good to actually start easily. Then you need to use a Docker file in order to optimize the service as well, which let's say I'm using Alpine, and you get here additional optimization values and so on. Let me check you if I have a few questions here. Yes, so Emmanuel had a comment that Docker file is better because you may not have access to the newest version like Java 16. Yeah, indeed. So in your Docker file, you can run any service, any library, any platform language, whatever you want, even Fortran to say so. It's very, very good and very productive in order to be portable and so on. Sorry for the coughs. So let's go forward after our quick demo, and let's see what options we could leverage when you deploy your project. So as I mentioned, there is a way to run on Cloudrun, which is fully managed. You have no clusters to manage, and you pay for what you use. I will show you immediately what that means. You can run also for Entras, which runs on your Google Kubernetes engine. This is GKE cluster, or on premise. So there is a way to actually connect your Entras from on-premise environment, and then you can run Cloudrun to actually hop on your on-premise environment in one of your Google Kubernetes cluster. So pay-per-use, this is tricky. Yeah, indeed, Emmanuel, I get some comments lately. He mentioned that Fortran made me caulking. Yeah. It's a legacy system, so it's indeed, it makes you caulk sometimes, but even some other legacy systems as well. So pay-per-use, Google Cloudrun actually makes you to actually pay by the CPU memory and number of requests. So you have a lot of way to optimize this for your situation. You could build a service that has a small CPU, you could build a service that has a large memory, you could build a service that has no traffic, or let's say hobby homepage and gets only 50 requests in a month, or you could build out a service that gets 250,000 requests in a second. So there is a big scale, and you need to pay the request. That's the duration of the request. So if you have multiple requests spanning, you get the out of it, you get everything, which is when the container started and when the container actually stopped serving applications. So if you have, let's say, an instance, you have a cold start because you didn't have any active instance, no traffic to it. The Google Cloud Run starts the instance. In a short time it will boot up. The request will wait, so it will be a fraction of time there to actually boot up. Then the request is being served. If there is another request meanwhile coming in, it will be served immediately by that container if concurrency options let you to do so, and you are actually paying the overall time of it, and the instance time is actually the whole one, which is not billed. So you get only the billable time, which is the last request with the first request, and so on. It's very straightforward, it's very helpful because it lets you to run concurrency and so on. There are some prices here, but you need to actually make the calculator in order to get your requests for the serverless application. Literally, you have 4 million requests, 40 cents, and 2 million requests per month are free. So I'm using for a lot of hobby projects or projects where I don't get many traffics and so on. This is just the basic package, which is 1 CPU and I think gigabyte per second, 1 gigabyte of a container, but you can run also 256 megabytes containers as large, so even smaller containers are fine for it. So let's review, because we are developers, we are at a developer conference. Let's see why developers consider Cloud Run the king of serverless compute, and hopefully I will have time to actually finish this. There are 5 topics to cover: dependency, testing, traffic controls, portability, security. So let's jump to it. Dependency. I put it here easily to actually have it in the red. All the legacy function as a service solutions with restricts you the tools provided. You have a certain language, you have a certain version, which could be from 2 years ago, and it's very hard to actually run any custom things on it. In the Cloud Run environment, you can bring any dependency, any binary to your application, because it's a container. So regardless of your language, runtime of the core, you can use whatever, and you can combine. So don't forget that next to a Node runtime environment, you can run a Golang binary, you can run, I don't know, a PDF generator, people package inside their application in a different language, and so on. So it lets you, the container story lets you actually to run all the elements of your application. Testing. So here, serverless tools make the promise of an emulator, production compatible environment. I'm not the favor of emulators. They are not the right way, and if you have a large application, network topology and so on, it's actually hard. Containers, in the other way, make the testing experience a lot more consistent. Code and dependencies are being packaged together, so you get clearly the packages and dependencies all in that container. And I'm seeing in the past, by running junior teams and team leading as well, that resulting a fewer works on our machine moments. So actually you get the testing a lot more easier. People can run quickly the environment. I'm jumping a bit to my VS Code. So there is another command here, gcloud beta cloud dev, which actually starts the local environment for it. What I missed here, beta gcloud, something I typed wrong. Yeah, so it's building out the container as we are speaking to it. It will take a few minutes on my PC to actually build it out. but it builds out a mini kube environment, Kubernetes environment on my local station to actually test all my applications. So we have some sort of emulator, we have some sort of live coding environment because it's our own container, and it's based on containers, so it's the same for everyone in the team. Now, platform-wise, in the network, we have traffic controls. Serverless tools don't provide canary deployment, subset of traffic, or legacy versions to actually deploy, but Cloud Run allows you to actually have traffic control across revision of a service. So you are able to, for example, deploy a service with the flag no traffic. You get a revision, let's say revision 20. It doesn't have any traffic, but you get a URL for that revision, a specific URL, and you are able to run your test. When your tests, for example, finish and it's a successful one, you can make a candidate one. That revision, it could be revision 25, let's say, and you can have a gradual rollout strategy, which means that the candidate can be set to accept only 10% of the traffic. 10% of the traffic will reach your container, which reach your revisions, and in case of any, let's say, exceptions, you will notice it and you can retract that version, or you can push out to 100% of traffic. Easily, each of these are specific revisions, are specific containers with small and major changes as well. It's very easy to actually deploy. You are not afraid of actually hitting the traffic if you get this no traffic option into the deployment phase. Portability. So with the function as a service platforms, you have a vendor lock-in. You need to build either Amazonish way, either Google-ish way, either IBM-ish way, either Microsoft-ish way, what you can build out in the vendor lock-in environment. But with Cloud Run, with containers, you can run your own environment. So you can have that environment also on managed infrastructure, also on Kubernetes, also on on-premise environment, and you can have the container even one day to actually be part of a VM. So you can boot out a full VM, which is 24/7 there. It's not anymore serverless, but you can build out your own VM based on the containers as well. Security. I didn't mention any function as a service security pain points because they are good as well. I want to actually showcase here what additional other options we have on the serverless and on Cloud Run way. So we are able to mount secrets from Secret Manager. This is an awesome feature, so pay attention, and you should run your secrets using mounts. By using mount, you means that you have the path, you have mounted the secret as a path, and every library, every system has a way to read something from the disk in a diskish way, and that way you can read out API keys, you can read out any other information, and it's ensured that all the updated keys are always mounted. So whenever another administrator changes or refreshes the API key of a service, it will automatically remount to you, and it will be transparent for you. You don't need to actually, change your environment, to shut down, to reboot, anything like that. Binary authorization and customer managed encryption keys are for regulated industries like financial services. And binary authorization is a nice service. It means that you have a policy to set that these containers can be, let's say, deployed to production or built as a container. And you have their policies from your organization which containers are whitelisted to be deployed. This way you ensure that there is no, let's say, hijacking of a container path, there is no additional multi-stage build hidden inside your Docker file, and all these are extremely nice features, not only for enterprises, you can also have for simple projects as well, and you can check it out. Customer encryption keys means that you are able to provide the key file that will automatically encrypt your container, and not even, let's say, the cloud vendors are going to reach your container. They are not able to get inside. There is no robot feature that you can do something with it. So all these are results in increased security in your services. So pay attention for this binary authorization, which is a nice feature nowadays when hackers can actually hijack a container or a multi-stage build and so on. Now, let's see some practical use cases, because this was a theory. So let's see how we are mitigating, for example, cold starts. The basic stuff is that you can use a linear base image or use global scope, declare global variable, cache reduce latency for Windows. But I want to actually showcase two additional features here, which are the minimum instances and always on CPU, which is in preview. It was launched last week. It's a very new feature. Minimum instances, it means that you can set a number like 3 instances, and when you have a traffic for it, you have 2 additional instances standby and you get a lower price. And I love this feature when I get something with lower price, and they are called idle instances or minimum instances, whatever they are. We are using the naming convention. So I like that when I have minimum instances ready and I pay only the fraction for it in a serverless world. It's really useful for any application that is an API, or it's let's say a website, but otherwise it could be very helpful for all the services where you have a quick way to actually show. Let me jump here. The quick way to actually respond to any request for it. Now, always on CPU is a different one. Here you have a command. You can have here minimum instances set and always on CPU with no CPU throttling. I'm showing the developer options, but you have also on the UI, you have a minimum instances of 0 or 100. You can set 1 in order to reduce the cold starts. Cold starts are around 1 and 2 seconds, but it really depends how big is your container and how fast it reaches the endpoint for the HTTP health check and so on. CPU allocation, let's say that I mentioned that the container is fully booted, but when there is no request on the container, it takes out the CPU and you cannot finish any background test that you did run. For that, there is CPU always on option, and then you get the CPU always on even to finish background processing. And this is a feature in order to reduce you also from the price and billing components as well. So there is a chart here to actually show you that there is an instance which is booting up, it started and then it's getting terminated. You have some requests, some are overlapping requests here and some are standalone requests. With the CPU, what you get charged is when there is some service on it, like for example booting up the container, you are using the CPU. Here there is a request, it's actually 2 requests overlapping, the blue and this blue, and then you have here another separate request as well. With the CPU always allocated, you get every CPU allocated, and here you have a 25% and 20 from the memory reduction from the price as well. Now this behaves as a full VM, so be aware, it's not let's say full serverless, it behaves as a VM. But you get all these nice deploy features, all the additional managed security for it, and you are quickly much more cleaner way to actually build your application. You may have always on CPU only for a fraction of the day. So leverage this feature, because you could have, for example, always on CPU only from 9 to 5 or 1 to 2. The other times you can stop always on CPU and respond slowly when the new request is coming up and you have the cold start. Now, auto scaling. When there are no requests, scales down to 0. This is serverless. Each service can scale by default to 1000 container instances. If you are a big customer, can be increased. Each container can handle up to 250 simultaneous requests. I think that it's wrong here. I've seen that it was raised to 1000 requests simultaneously. I need to check the latest product announcements and fix my slides. But if based on these examples, you are able to actually handle 250,000 simultaneous requests. And these are a risky way to actually set up your cloud environment to accept so many requests. So let's talk about concurrency. Function as a service frameworks has a fixed concurrency of 1. Cloud Run enables you to set concurrency. Default is 80, but can be increased up to 2050 or 1000. I'm thinking now from last week. But a free trial experiment can end with a very overnight bill, a very large bill, because you could, for example, have uncontrolled retry, loops, failing tests, missing backups. I'm seeing people that they got in a failing test in a loop. So they are doing the test, they are doing the test, they are doing the test, and it never stops for it. You can stay on the talk even if you get the notification that this talk has ended. So hopefully we'll get to it. Woo. I'm continuing anyway. Let's see what's going to on. I may have any 15 minutes. So let's see what screen on the car comes out. Good. So you can, with the common error is that unwanted traffic, you have reduced concurrency, and you have DDoS problems, errors that could happen on your interface. So that way, working with concurrency is helpful, and you need to actually build out all the stronghold settings for this. So this means that you need to set your concurrency level nice, because for example here you have concurrency 1 and 400 clients with 300 requests, you get 500 instances started. So you are paying all the CPU, all the memory for these instances. Now if you set the concurrency to 80, you have 150 instances with the same client and request number. What it means, if your container with the CPU and chosen memory can handle the traffic, you can increase the number of concurrency up to a certain point, but it's good to actually set this concurrency up. You can set up a load balancer in front of your Google Cloud service. It lets you to run your URL map or a forwarding rule for any service in your container. You can have a multi-region load balancing as well. You can deploy your Cloud Run application to a region. The same Cloud Run application can be deployed to another region, and your container will actually boot based on, let's say, the user in the Oslo, it will be routed to the Europe region. User in the New York, it will routed into the serverless way. Now I have another demo, but I want to skip that demo because I've run the demos as well. Conclusions. You have a simple UI and command line options to actually quickly deploy and manage services. You have a direct integration out of the box with Cloud Code, Cloud Build services for continuous deployments. You can set up for automatically kick the deployments based on the GitHub actions, for example. Out of the box, scale down to 0 and fast auto scaling for you. It has redundancy services replicated in multiple zones as well. And it out of the box offers you custom HTTP endpoints and custom domains. So you got in my demo that I got let's say a hashed domain, but I can actually wire in my custom domain for my services as well. And some services are for HTTP2, WebSockets, and gRPC. So you can run in a serverless environment WebSockets, you can run in your serverless environment gRPC services. So this concluded my talk. Hopefully it was clear and you got a lot of from these services, how you run Cloud Run services. Slides are available on slideshare.net Marton Kodok. You can check it out. You can place any questions inside the chat, as Emmanuel noted some of his thoughts as well. And I know that there is a schedule, an ending keynote starting soon, but I want to actually, now that I finished the presentation, to see how we are going to use, and if you want to actually stay longer in order to demo the WebSockets part, I want to demo the WebSockets part in a serverless way. So if someone wants to see that, let me know in the comments to actually stay longer and show you that. Good. So I'm going forward with the WebSockets demo. Oh, I started in the middle of the presentation that I've used the demo environment in order to run the local code dev. So here there is a local host. Oh, where is? Yeah, it's here. Let me choose. Oh, nice way, but it's not right. And then whoa, it went over. So here is my environment to actually run all this from a local host as well. The nice way is that whenever you are actually change something, you are able to get your container rebuild, and automatically you get the container rebuild automatically locally. So it's a nice way to actually test out some services. Here you can write anything and it will automatically wait for the changes and change the website as well. You can build out a lot of application this way. Again, the command for this one, let me stop this, was gcloud beta. This is a beta feature. It was launched recently, code dev. Let me see where it is. Here. gcloud beta cloud dev. This is the command that actually starts an environment on your local PC. Now, I prepared another demo. There is Socket.io, and they have some examples. This is the Git repo of the Socket.io, and they have here a whiteboard, public example about a whiteboard. Let's see how that builds out. So I'm going to Socket.io examples whiteboard demo here, and I'm going to deploy because this is faster than booting out on my local machine. What you see here is that it's building out. It's uploaded the sources already. Now it's building out the container, and we will get hopefully in a minute the new container up, and the demo should be running soon. I will arrange the screens a bit because I need 2 screens for it. And what will be the awesome thing to see is that it's based on a WebSocket. So I will have 2 screens, and what I'm going to do in one in the other, I'm going to see it because it's automatically connected with the WebSocket environment as well. Now, come on, containers, and you should notice that this folder doesn't have a Docker file, so it's figuring out to Docker file it. That's why it's a bit slower. I'm going to check the logs to see, yeah, that was the logs, to see if there is any error, because it could be that there is an error in the container. No, it's already built. Good. It was green because I have seen it is successful. Now go, it's creating revision, it's routing the traffic, and we get the URL in a moment. Now we have the URL. This is the URL of this deployment, And now I'm going to add this inside my screen and zoom out. Good. So this is, let's say, screen A, and this could be your application. This is screen B. And what you see here is the two applications which are, let's say, are on a different environment, on a different platform, are here and can work together. And all this is serverless, so it's Socket.io and WebSockets inside the environment. So it's really nice to actually be here. And this concludes my presentations for today. Hopefully the demos made you the service and how you run. It sounded like DevOps, these things, but these are for developers, containers, and all this is publicly accessible. As I mentioned in the, let's say, you could check out the Socket.io whiteboard example as I run it, and you are able to enjoy all these awesome features of it. So thank you for having me here. Where is my final presentation screen? Here. And see you at the next event. If you have any questions, reach out for me on Twitter, for example, under Marton Kodok, and I'm happy to actually answer you and hop on a full remote code session as well in order to get you going and so on. Thank you for having me here. It was nice.